at Loughborough University. I'm quite happy to have to be talking after John. I'm very interested in a lot of work that he does, and I have a background in engineering, but I've spent most of my research career trying to incorporate kind of behavioral and social science insights into engineering, and in particular engineering models. So I'm a modeler. I model kind of energy systems, and I'll talk about that in a little bit. Just a little bit about CREST. I mean, CREST is one of the largest sustainable energy research centers in the UK, and it's been around for over 20 years now. And I think it's quite relevant to some of the work that's going on here, because we have expertise and we do research in kind of all aspects of renewable energy. So wind power. We are one of the only 10 accredited laboratories for PV device performance measurement. And we do quite a lot now in energy storage. There's obviously a lot of interest in energy storage and how that can be used to help achieve a low carbon future. My particular interest is, I'd say generally, it got to do with the challenges of integrating renewables. How do we get towards power systems that are where we have high penetrations of power from intermittent renewables? And I mainly focus on technical challenges, so I look at power systems modeling. So I try to model the power system of, for example, Ireland or Great Britain, and forecasting into the future, given the targets that we have for meeting for decarbonizing the power sector. I also look at modeling at the low voltage distribution networks, because there's an expectation that we're going to have a lot more electric vehicles, electric heating, and that we might be able to use those to help give flexibility to the system. But in terms of modeling on the low voltage distribution network, I therefore spend a lot of time looking at energy demand in buildings, and doing so and modeling that in kind of very high resolution, and building bottom-up models that are based on human occupancy and human activity, and trying to associate appliance use to activities. But more specifically, within this challenge of integrating renewables, I look at storage and demand response, and trying to quantify the value and the role of storage and demand response in terms of securing a low-carbon power system. I have done a number of research studies looking at electricity storage, like batteries. So, for example, in the UK, we have lots of domestic PV systems that are grid connected, and due to the feed-in tariff that we have there, people are incentivized to put batteries in their homes. And this is a situation where you have an economic incentive for adding storage to power systems, that the research that I've done shows that, well, in fact, it's not a green thing to do. Actually, you're very likely to be increasing carbon by adding more storage to the power system. So just when it comes to storage, I just wanted to say that there's a lot of interest in it, and I think it's important that we evaluate it properly, such that we're getting the economics correct, but also the environmental. So I have a fair bit of experience in that. But what I'm interested in particular here is to do with demand response, and the position paper that I sent for the conference was to look at the role of demand in order to coincide with the availability. And what I did in my PhD was they react are and understand them, and then have a domestic at how they change that they produced by the PV is that they want behavior and produce. And the fact that this idea that value that someone has in it to kind of behavior or behavior or energy. And to take your question. And my research is evaluating that box within a system and for a particular application, and deciding whether or not actually it's producing something that has economic, environmental, and social value. There's a huge range of kind of energy storage technologies, and there's lots of talk about costs going down. So it's quite possible that existing technologies already are going to get cheap enough to be viable, but there's lots of interesting kind of new research being done in terms of thermal energy storage technologies, and just to say that's an area where there's lots of new research coming there that could be very kind of low cost. Yeah. Can you disaggregate the demand into the appliances?
So right now we are still working on it. There are different kind of techniques that are basically exploiting voltage, you can basically use the frequency. Someone was presenting this morning. So you can use both current and voltage to get some signatures, some features by analyzing the voltage and the current into different domains, time and frequency. So yes, in principle, yes. I think the main problem of those kind of techniques is, again, you have to go there, you are using some techniques, support vector machine, some machine learning techniques. I will not go too much in deep about technical issues, but you have to train your system. So in order to enable, to understand which kind of appliances are you using. In every house there are different appliances, different kind of loads, inductive loads, ohmic loads, capacitive, and etc., etc. And it's really hard to find someone that can train your system for 1 week, 1 month, 1 year, and your system will change. So I think the most complicated part of this is not the technical issues on recognizing appliances. You can have a system that is more, I would say, more precise, so it can recognize 90% of the time the appliances or 80%, but the problem is the training part.
Good afternoon. My name is Wilson Negrão Macêdo. I am professor at the University Federal of Pará, north of Brazil. And I am a research of the group of development of alternative energy, called in Portuguese like JEDI. In this group, I coordinate the photovoltaic system laboratory, and beyond that, I am associated as a associated research. I collaborate with 2 important institutes that atuate in the north of Brazil, called the ECRS and IDSM. And I participate in the current management of the Brazilian Association of Solar Energy, called ABENS. About the details of my research area, I have divided in 5 parts, or in 5 themes. The theme 1 is about the monitoring and performance analysis of grid connected PV application. The scope is in installation, development of acquisition system, and analyzing grid connect application with different inverter topologies, with string inverter, with 3-phase inverter, and with optimizer inverters, something like that. Here you can see an illustration of the JEDI's laboratory in Belém do Pará. You have views of the JEDI laboratory in the University Federal of Pará. And here you have some systems that you have worked along the time. Another example, another grid connect application, that's it. We have worked in the Amazon state, north of Brazil, in the IDSM Institute. In the theme 2, we have worked with the monitoring and evaluation of the PV module, measured under real sun conditions. in the scope of analyzing PV modes with different technologies, monocrystalline, polycrystalline PV modules, amorphous modules, bifacial modules. And here you have the JEDI's laboratory PV module test field, when we made the acquisition of the data in real sun conditions. More details about this work you can find in this reference here. In the theme 3, we have worked with the monitoring and evaluation of off-grid systems to attend the electric demands in isolated area in the Amazon regions. Here you can see a PV solar home system to attend to supply a river dweller like that. You can see in this photograph. Some details about this work you can find in this oh no. More details about this work you can find in this reference here. Here we have another example, another off-grid system installed in the Uacari floating loading house. And we have a publication about the systems in the Progress in Photovoltaic. Still in the theme 3, we have installed the solar hybrid system, solar wind hybrid system, in a floating basin in the IDSM Institute in the Amazon region. And here you have the system, and here the data acquisition interface developed for monitoring these systems. Another that we have worked a lot is about the educational area. We have developed some instruments to help us in the training and in the capacitation of the people, things like that. Here you can see one of these kits developed for grid-connected demonstrations in low scale. And here you have the pump system, solar pump system, developed for demonstration of this application at the school, something like that. The last theme, the last part of the detail of my research area is about the studies of mini-grids with a hybrid power system. Our group have worked hard to develop a laboratory structure that with a mini grid, a physical mini grid, in a real system for develop the research to different configuration of the system, different penetration of the solar in different points of the mini grids in different load profiles, that we can reproduce it quickly. In my particular opinion, in these terms, is how our research area fits better with the terms of this workshop in particular. We have worked for more than 10 years in development of a hybrid system for attended community in the Amazon region, isolated community. And all this work was compiled in a book called the Hybrid System, and this book is available in these 2 websites, and you can download if it's without problem. Well, I apologize for my poor English, and thank you for your attention.
Hi. You've tried to work with kids. Quite clearly, you've been exceedingly successful. We've tried that too, and we've had our own experiences year on year, but our spots were very short. So the interventions were one-day interventions to groups of maybe 25 children, and we were only doing it for fun and for team building for our own team. So the PhD students design the experiments, and we do team building instead of going, I don't know, Go Apes or whatever other team building event. So for you, you've done it for proper and for good and seriously. And I'd like to hear what you felt were the outmost challenges in your view. Was it preparation for delivery? Were they to do with the delivery? Were they
the system for functional. And in our group, we have basically engineers, and we have a lot of difficulty to trading with people, to call to people, something like that. And the objective of the developers of the kits, the instruments, to in the tentative to approximate the people interacting with us and make them understand a little more about the functionality and the limitation of the application in that regions. So, because in these regions, basically, we're working with communities and where the people don't have a lot of much education. So it's much more difficult to interact with them. Thank you.
Good afternoon. My name is Anil Kashyap. Management remit as well as doing myself research which I am interested in. Coventry University, and sorry for framing this one, and that was one of the conditions that I'll be projecting this slide here in front of you, just to brag about, it's a good achievement. Modern University of the Year, 3 years in successive years, and it's ranked 15th best university in the UK. So fantastic place and fantastic environment and very good leadership in terms of coming from Elena's department as associate dean research. So please, very welcome you all to visit and have some experience of research facilities out there. I'm based in School of Energy, Construction and Environment, and there are other 3 components. So the reason here is that we are in one faculty, but there are opportunities for interdisciplinary research, which is my main objective, and I do inculcate that kind of approach in my my past research proposals as well as future opportunities. We have got this slide is not being clear here, there were some blobs, but we have departments or sections within our school looking at oil and gas, buildings, civil, disaster management and environment, and geography. So there is a lot of opportunity for synergy, and we actually then feed our research into faculty research center and university research center. So that's how the arrangement is in terms of the conducting research myself, as well as how I manage research within the school. My research interests are around community planning, because I'm an urban planner, I'm a civil engineer. My PhD is on energy efficient urban form. So I utilize a lot of those skills into the research interests which are around community planning and development, urban environment studies, energy efficient urban form, energy use, the behavioral aspect of that, decision support system, green buildings, passive house design. These are some of those research interests which I have been pursuing for last number of years. The impact here in terms of communities, this is perhaps the other slide presentation he has been putting up. So the impact here is basically, again coming to the smart communities, smart cities, and you can see a lot of interaction in terms of big data, computer interventions. So this is one of the area which I'm picking up quite strongly, and you might have picked up from the news, etc., that in India particularly, there are 100 smart cities being proposed, and 20 have been funded very recently, 2 weeks ago. So there is a lot of investment going on. So huge opportunity in terms of making that impact, and that's where I'm focusing my research, my intervention, my collaborations. So I work with a lot of policymakers back in the country, and intervene and advise on how that communities interface can work with the digital interface of the research as well. Earlier it was more about land use planning, about how to plan communities, how buildings, heights, etc., regulations. But it is now coming from the data perspective, where a lot of capabilities around the here around the table and in the room are very helpful. And obviously, we don't want to discount architects and designers as well. It has to be that integrative. My passion or my love with computer scientists goes back a number of years ago when we won an innovation fund for running a project called Decision Support System in Urban Regeneration. So we got a PhD student. He has already finished. So I worked with the computer scientists. It was more on a software which was hierarchical software. You would know more about that in order to make a decision rule. So it was a rule-based software which was created in-house, and the student applied that methodology into urban regeneration projects, and that was quite successful. There were a number of publications out of that. I have been working in, these are a number of fundings which I have been involved into. Framework 7, European Union funding on security, urban security. Someone in the room was talking about security as well. So that's where those lot of opportunities are there in terms of extending that idea and debate in terms of urban security. And Horizon 2020, which is European Union funding, is having urban security as a dedicated strand. And there are not many people working in urban security. My institution applied for 5 projects. Out of 5 projects, they got 4. So it is such a opportunity. So we can look at some of those ideas over the next few days. That's where I'm coming from. That's me here. Thank you. Any quick question? Okay, thanks.
forward, here you go backward, and here's the pointer.
Okay. Right. Good afternoon, ladies and gentlemen. And very quickly, I'll keep this very short. I'm probably one of the very few odd people here coming from a chemical environmental engineering background. But just to talk about my key expertise, my main interest is in waste to energy, basically. I do a lot in water and wastewater treatment design, basically. My background is from chemical environmental engineering, and my research, basically, it's probably triple-fold. I look at issues related to wastewater sludge, bioenergy generation. I also look at things on process safety, loss prevention, and another key area, it's pollution management. I'm a principal lecturer in petroleum and environmental technology. I often say it's a weird combination, but we're gradually becoming more aware of the importance of environmental sustainability to the petroleum industry. So in the oil and gas programs at Coventry, same school as Anil currently. My related research interests includes renewable energy. I spent my first 5 years of career in the oil and gas industry trying to solve problems, basically environmental and safety problems. And when I left the oil industry, I went to the water industry. And one of my primary responsibility as a process design engineer in the water industry was to optimize gas production for energy generation. And basically we had anaerobic digesters, and municipal sludge had to be digested to produce energy. The gas that is produced, we run it through Jembec. Most of them are 1.5 to 3 megawatt capacity. And what was happening was that those gas engines were operating below capacity. So there was a huge push from management to optimize digesters to produce more gas. So I spent 4 years looking at gas, anaerobic digestion optimization to increase gas production, to increase electricity production. Now, the electricity that we produced was sold directly to the national grid, and then we buy cheaper energy from the national grid to run our plants. But basically, I learned a lot doing that job, generating electricity from sludge digestion, and I thought that I could apply this knowledge in rural Africa. So I got involved in a project, and basically to help design small anaerobic digesters in a community-led system. So very shortly, that's me. Thank you very much.
Waste to energy.
Yeah.
Could you please tell me more about it?
Okay.
Yeah.
Why in the water industry? What we did was, after treating wastewater, there is what we call biosolids, which is sludge. Now, this sludge has a lot of energy in it. So we need to put it into what we call anaerobic digesters, where you break it down. So microorganisms will break down the organics and convert it to methane gas. Now, that methane gas is now used to either run an engine, usually a CHP system, so combined heat and power. And so we generate both electricity and at the same time heat. The heat we can use for heating, and then the electricity can be sold to the national grid.
Oh, okay.
Yeah.
And what happens if you have the domestic waste of a city, a large city?
Yeah.
Do you have any idea what to do with it?
The domestic waste. So typically, if you think, I come from solid left. That also gets burned in an incinerator, and the heat is also used to run it. Yeah. Okay.
Good afternoon. I am Jakson Bonaldo from Federal University of Technology, Paraná. It's a pleasure to me to take part in this event. I graduated in Augusto, Brazil in 2008 and hold emphasis in power electronics, Antônio Pomilho. From Campinas that manufacture backbone. With the Department of Electric depending on the radiation curve of a solar panel, for example, there may be that the pack exploited. Okay, so of the voltage at the compensation of grid imbalance, the grid voltage balance. Okay, and even with a distorted load, why? Because the grid is a part of the load current. Okay, but there is multifunctional.
Hi, Jakson. What do you think are the most stringent criteria for supply management, demand? How do you think it should be done? What do you think should come first? What are the
power where converters or even in traditional